In this video, we are discussing the asynchronous version of the magnetic force on a wire lab. In this lab, a wire is suspended inside of a magnet that is on top of a scale. By applying a current through that wire, we create a force between the wire and the magnets that are producing the magnetic field, and that change of force will be monitored by the scale. In this equipment, the wire is being held stationary, and the magnet that is producing the magnetic field is free to move on the scale. That means the readings that we will see are not the force on the wire, but the Newton's third law force that ends up going on the magnet. So if there is a downward force on the wire, that would be causing the magnet to be lifting itself up on the wire, and we will see a decrease in the effective weight of that magnet. Similarly, an upward force on the wire would cause the magnet to be pushed further into the scale, and you will see an increase in that mass. We will be measuring that change in force under three different conditions: changing the length of the wire with a constant current, changing the current in the wire with a constant length, and changing the orientation of the wire when compared to the magnetic field at a constant length and current. When you are looking at the applied force, you will notice that a lot of the time, the last couple decimal places on the scale never really settle down. That is okay, and that is fine, because we want it as sensitive as a scale as possible, which means it is noticing those little fluctuations due to things like wind currents in the room. The effects that we are going to be looking for due to the current going through the wire are going to be larger than those last few decimal places that are wiggling. So very quickly, when you're taking this data and you can start to look at the results, you'll see that the effects are much bigger than the wiggly decimal places at the end, and you can just get something that is close to right. That if it seems to be fluctuating between, if the last decimal place seems to be fluctuating between 4, 5, and 6, you can just write 6. That'll be enough precision for this experiment.
Thank you for watching this video. Here is your fun fact of the day.
The European robin can see magnetic field lines, but only with its right eye. If their right eye gets damaged as an adult, they can no longer migrate.